Okay, so this is the second topic area we're going to cover uh, dealing with Microsoft Access. All right, so talk about one of the concepts I think if anything that you should pick up by now in the course of this class is the idea of quality data. This idea of the importance of data and the importance of high quality data. And so you really your decision making is dependent upon the quality of the data, the accuracy of it, the effectiveness of it. You can put whatever computer system you want in place, but if you have fundamentally bad data going into it, the results you're going to get are going to be suspect at best. All right. So the term to get, and this is a very old term in the computer world, garbage in, garbage out, GIGO. So this is basically if invalid data is entered into the system, the resulting output would also be true. And it's true, it was originally for software, but it's actually true for basically across the board, especially things like decision making systems. Okay, so we talked in our first video, we talked about Dr. Cod and his rules. All right. So there's a bunch of stuff. I think there's like 10 rules, but these are some of the core principles. All right. And these are the very very important core principles. All right. So there's three types of integrity. So if you want to have a proper database, a proper working relational database, you have to have these three. You have to maintain three types of integrity. All right? So this first type is what we call entity integrity. So entity integrity means that every record in a table is unique. Every record has a unique value in it, which makes it unlike anything else. So the way you do this is usually through the primary key, and making sure you pick a unique primary key, whether it's one field, whether it's multiple fields, whether you use a surrogate by just simply putting a field with a number in it, whatever it takes to make that unique. All right, so that's one of COD's first core principles. Um, the second design rule is something we call data integrity, and data. The tables are designed. The expectation that tables are designed to collect and store only valid data. So so the idea behind this is that you establish a set of rules for what the data should look like, and the database management system will enforce what those rules are. So if you say a field should have a date in it, it will have a date in it, and don't, you should not have an expectation if you've got a million records, that 3% of those have dates in, only 3% have dates in them, so that's or actually conversely, 97% would have dates in them and 3% would be off. Right? So you want to be as high quality as possible. So that's really the essence of this principle of data integrity. And then the third design rule we have is what we call referential integrity. All right? So referential integrity basically means that two tables um, are connected together basically using the relationship between two tables is established by having a common field between the two tables. All right. And referential integrity means that the the information that's in that field is accurate. So we'll take, for example, if you have two tables, table A, table B, you have a common field in each one, but in table B, there's an entry that is not found in table A. Then you have flunked the referential integrity test, because what will happen is that particular that particular table, when you do a query against it and you try to do a join against those two, it will return really what should be considered an invalid set. All right, so the referential integrity, it's a little more esoteric, but basically it deals with the management of table relationships. So it's a bunch of stuff you can do to maintain validation of data, a whole range of things. So accuracy and integrity of data. Um, you can check for dates, you can check ranges, you can check for consistency, you can check for completeness. All right, and the way this works is you put that into a rule for that particular column or field in the database when you design the database. So the database itself is the enforcing mechanism to make sure the data will stay valid. And usually it works. Every once in a while, I've actually seen in real life somewhere along the line, somebody will find a way to get something in that's wrong, and you discover it later, and but usually it takes, it's usually some exceptional circumstances. Okay, so this is some guidelines around your data integrity and database design, field properties, which is in Access what the characteristics. So the main ones: data types. Is it a date? Is it a numeric? Is it alphanumeric? Is it currency? So there's a full set of those. Some appropriate field sizes. So what will happen is you've got some default field sizes depending upon record types. But you would define, like, for example, your date would be like 10 characters long. Is that four, and 2? So it would be month, day, year with some sort of spacer in between. So that would be, you would set your date field to be 10 characters long. You can use a format property to establish what the format would look like. For example, telephone numbers or social security numbers. You can share using captions. You can set a default value. And a lot of times this is a good thing, because a lot of times what will happen is, if you don't set a default value, the value and nothing gets put into a field. It shows up as null. All right. So a null field, and a lot of times what will happen is that you have to go back and retrofit all the nulls, identify all the nulls, and replace them with some sort of default value. So doing this up front, setting a default value up front is a best practice. Make fields required. If it should be required. If something is not required, you don't have to force it. But if any fields that need to be there should be set as required. You set the validation rules. You have lookup fields. So lookup fields is, say, for example, a situation where you have a number, like a zip code. All right. What a lot of times in applications, you'll create another table, which will have all the valid zip codes in it, and you can match, do a lookup against that table with that key to make sure it's a proper zip code. And then also your input mask. So masking is another means of being able to enforce a rule around how data should look. So this is this is Access specific stuff here. So this is basically, if you have a field format, basically if you want to see all your characters display in uppercase or lowercase, you can use these characters. This is a placeholder for a character, and you can actually put a color. And you can actually put a color into a field. So this is, as I said, this is more of an Access. This is specific to Access, not, you wouldn't necessarily see this in Oracle. But just some examples of field validation rules. So, male or female, or invalid, in X. Dates, so, something equal to or less than a date range. Something that would fit that. Or if it's null, you say, if they're both null, field 1 is null and field 2 is null, that's an error. That would be an error condition. So this is just some examples of the different types of validations you can apply to help improve your data quality. Test your validation rules, making sure that the rule's written correctly, making sure that any data is already written is verified against the rules. That's actually one of the ways you get bad data into it, is you'll set a rule, and then for some reason somebody will turn the rule off, and you'll load a bunch of bad data into the table, and then you turn the rule back on. It won't necessarily go back and verify all of the data that's already in the database. Now, what will happen is, if you go to update that field, when you try to update it with that bad data, it'll fail. So you'll find it eventually. Okay, lookup fields. A display of list of values from which a user can choose can be directly entered. Once again, these are access types of functions, display control options, which are specifically designed to help streamline and kind of you know present a list of valid um, entries, as opposed to just simply letting somebody just key whatever they want in and go back and validate it. Input masks, basically describing what a field would look like. One of the challenges you run into with changing attributes after the database is set is if there's already data in there. So if you change the field size after you already have data in the table, your results may be uh, unpredictable. Or if you change the validation rule, add a validation rule, eliminate validation rule after it's already been set, then the consistency of your data can be at risk, or a required field that wasn't required before and now is required, or vice versa. So some basic relational principles once again. So this goes back to Dr. Codd and all of his research and work. Relational database of relations are made in the relationships window. So this is actually a description within Access. There's actually you can, and we'll see this later, where you can connect the two. You can take two tables and actually connect them together. Or Access is, if Access, if depending upon how the tables are set up, Access can actually try to do that automatically for you. Idea of having a primary key. It makes, a primary key is one field that makes that row unique. It can either be just a number generated, or it could be something that has an attribute that guarantees that it would be unique. We can use, in order to make something a primary key unique, we can combine multiple fields together to make a composite or concatenated key. All right, so remember, a primary key does not, repeat, not have to be a single field. It can be constructed of multiple fields. All right, and then finally, this idea of a foreign key. So a foreign key is, we'll see this when we start talking about relationships and queries of, being able to connect. Basically, the foreign key is the column of which column which contains the values which are also present in the other table. So basically, what you've got is the primary. You'll have the one table. You'll have a column. The other table will have a column in the usually it's the many field. So if you have a one to many relationship, the many field on that side, that would be called the foreign key. But basically, it's the key. It's the key that is used to establish the relationship between two tables. So this is a relational database, which is probably more. Yeah, this is more generic. So this is more generic. So the idea of how you design one of these things. So you say this is a process. This takes some time to do. So you want to define the purpose and scope. What is it for? Because remember, databases should model businesses and business processes. All right. Identify your major objects. Once you have your major objects, then you go through and identify your specific details. Define a primary key for all of the fields. You want to set the data type and the size, and then you establish whatever additional restrictions, format, lookups, whatever additional restrictions can be on the data. And then finally, the last step is if you have more than one table in a relationship, then what you do is you establish the relationships between tables. All right, so that's really the steps of creation of a relational database. We talked about these different kinds of relationships. So there's really three. First one is what we call one-to-one. All right, so basically, for one entry in one table, only has one and only one entry in a matching table. All right, one-to-one. And many-to-many, we'll skip over one-to-many for a sec. Many-to-many is every table, every row in one table matches to all of the other ones. So this is the term that gets used for this is a Cartesian product. So what will happen is if you take two tables and basically combine them together, create a many-to-many relationship, what you'll end up with is the result set is going to be significantly larger than the two originating tables, primarily because it's all combinations of different things. All right. And then the third one we have, and this is probably one of the most common ones we have, is one to many. And the relationship is basically for one entry in one table, there are multiple entries in another table. Best example of this is in a sales order. All right. So sales order, you have a header information, and we'll see this as we go through our different exercises. A sales order will have all of it. Will have all the data that's relevant for the order, and then everything that's purchased, all right, is in another table, all right, and you can have multiple. So you could buy one thing, you could buy 100 things, you could buy 1,000 things, all right. So that's the one. That's the one into many relationship. As I said, that's pretty common. We'll see more examples of this as we go through. So this is how we do this in Access. So this is an Access thing. Basically, you can, the relationship, you can enforce referential integrity, cascade updates, cascade deletes, delete. So you can see this is the entity relationship, uh, between two tables, the one field between two tables. Um, you can enforce the referential integrity. You can actually enforce whether, if you delete a field, whether it will go through and delete all other references across both tables. We see a relationship type of one to many. You can also do this actually using a drag and drop. So, and that is really all we have to say about that.